Energetics Part 2. Standard enthalpy change of combustion. It is enthalpy change measured at 100 kilopascals and a specified temperature, usually 298 Kelvin, when 1 mole of a substance is completely burnt in oxygen. Experimental determination of enthalpy change of combustion of a liquid. To find the enthalpy change of combustion of a liquid, unknown mass of the liquid, in our case we're going to use ethanol, is burnt, and the heat energy released is used to heat a known volume of water. Calculating enthalpy change of combustion, we are going to use the formula Q is equals to mc delta T. Now Q represents the heat energy, M is mass, C is specific heat capacity of water, and delta T is temperature change. In our case, we've been given the following information. The volume of water is 100 cubic centimeters, the mass of ethanol is 0.42 grams, and the temperature change is 24.5 degrees Celsius. So using the formula Q is equals to mc, change in temperature. We key in our information. Now for the mass of water, we assume that the density of water is 1 gram per cubic centimeter times specific heat capacity times the change in temperature. Change in temperature will always be the same regardless of the units, be it in degrees Celsius or be it in Kelvin. The value we get will be 10,241 joules. We convert that to kilojoules, where we know that 1 kilojoule is equivalent to 1,000 joules. So we get 10.241 kilojoules. Step number 2, we find the number of moles of ethanol. We know that number of moles is mass divided by relative molecular mass of the substance. We get our value as 9.13 times 10 raised to power negative 3 moles. Step number 3, we calculate now the enthalpy change, where the formula says enthalpy change is equals to negative Q, which is the heat energy, divided by N, which is the number of moles. You can pause so that you check that out. Now, after doing that, we get our answer as negative 1,120 kilojoule per mole. Sources of error and assumptions in the experiment. Some of the heat energy produced in the burning is transferred to the air, so that is lost. Some of the heat energy produced in the burning is transferred to the copper. Again, that is lost. It's not going into the water as we want. Incomplete combustion of some ethanol. Therefore, not all the energy from the ethanol will be transferred to the water. The conditions are not standard, e.g. water vapor and not liquid water is produced. A summary, defining standard enthalpy change of combustion. Remember, this is the enthalpy change that occurs under standard conditions when 1 mole of a substance is completely burnt in oxygen. Understanding the simple experiments, be able to process results and calculate for the value of enthalpy change of a substance. That is part 2. Thank you.